Good day everyone. I welcome you today to another exciting video lesson on Macro Science Guide. Now in today's video lesson, just as how you saw in the thumbnail, preparation of arcades, precisely the Wurtz reaction, alright? And that's what we are looking at on the board, the Wurtz reaction. Now this is one way you can prepare an arcade. With this reaction method, you can be able to prepare arcade. But here's a little hack to Wurtz reaction. Now Wurtz reaction can only be used to prepare even numbers of arcanes. Alright? Wurtz reaction can only be used to prepare what? Even numbers of arcanes. Now what are even numbers? Even numbers are numbers that can be divided by 2 without any remainder, right? So when we are talking about even numbers, we're talking about numbers like even numbers include 2, 4, 6, 8, 10, 12, and so on and so forth. Are you with me? So the Wurtz reaction can be used to prepare alkanes with 2 carbon, 4 carbon, 6, 8, 10, 12, 14, 16, 18, 20, just like that. Now, what does this reaction entail? The Wurtz reaction talks about the reaction of alkyl reaction of 2 alkyl are you getting it, with sodium in dry ether to give alkanes. Alright, reaction of 2 alkyl halide. There's a reason I just put these 2 alkyl halide here, alright, which is just for balancing sake, alright, just for balancing sake. So 2 alkyl halide with sodium in dry ether to give alkanes. Alright, now let me show you a practical reaction. Now when we're talking about alkyl halide, alkyl, remember your arrow, and then X is what? Your halide. Now X can be chlorine, bromine, alright, or iodine. Okay, chlorine, bromine, or what? Iodine. But then the halide that is commonly used in reactions is chlorine, the Cl. So now let's think of any alkyl halide. So think of any alkyl group. Could be methyl, could be ethyl, could be propyl, could be butyl, anyone. So let's start with the most simplest alkyl, which is what? Methyl, CH3. So we have CH3. Then our X is most times it is what? Chlorine. So CH3 is Cl plus sodium, all right, in the presence of what? Dry ether. So dry ether. Now what are we going to get? What are we going to get? We're going to get what? Now remember, it is used to produce even numbers of alkanes, even numbers. So one of these, now this is the reason why I tell you that I'll just use 2 alkyl groups. So it means that if we are using 2 alkyl groups here, all right, so that's these 2 alkyl halide, sorry, the alkyl halide. So this is methyl chloride, which is an alkyl halide. So two of these will now give us, remember we are using methyl, right? Methyl. So and we need to get what? An even number. So what's the even number that is very close to 1? What's the even number that is very close to 1? It is what? 2. Alright, so we'll now have what? CH3, then plus NaCl. So now, if to balance it, we already have 2 carbon here. So these 2 is also affecting this chlorine, and there's 1 here. So we'll put 2. Sodium has automatically become 2. So I just put 2 here. So now you discover that methyl chloride give birth to what? Ethane. Methyl chloride, all right, produces what? Ethane. Now, what happens when we use what happens when we use another alkyl halide? Let's say let's take it a little step higher. So instead of using methyl chloride, let us use ethyl chloride. We have CH3 CH2Cl. Now this is ethyl chloride. Am I right? Yes. So this is ethyl chloride. Now plus sodium in dry ether. All right. Now we use two alkyl with 2 carbons, which is ethyl chloride. Now what are we going to get? All right, we are going to get an even number alkane. Now the even number alkane, that is, very close to 2, that is an even number that is close to 2. After we have 2, I give you a list. After 2 is what? 4. After 4 is 6. All right, so we use 2 ethyl chloride here. So what do we get now? We will now get what? Butane, CH3 CH2 CH2 CH3, butane. All right, then plus NaCl. So when we are trying to balance, this is 1 2 3 4 4 carbons. So we just put 2 here so that it becomes 2 plus 2, that's 4. So chlorine is 2, so put 2 here, and then we'll put 2. So this is the reason I always tell you that is why that statement I put 2 alkyl halide, right? 2 alkyl halide. So because you must be having 2. Now here's a shortcut. All right, here is the shortcut. In what reaction, any alkyl halide you are giving, just multiply by 2. Any alkyl halide you are giving, just multiply by 2 to get the alkane. This is the simplest arc. Multiply by 2 to get the alkane. So if I tell you to use propyl halide, so that is propyl has 3 carbons. So propyl is an alkyl with 3 carbons. So CH3 CH2 CH2 Cl. All right. So to react with sodium in what? Dry ether. Now, how many alkyl do you have here? 1 2 3. So 3 abi. Now multiply 3 by 2. What would that be? When you multiply 3 by 2, what will it be? 6, right? So therefore, propyl chloride will react with sodium in dry ether to give us what? Hexane. And hexane is CH3 CH2 CH2. One guess is 1 2 3 CH4 CH5 CH3 6. So this is hexane. All right, and then we'll get what? Balancing it, we have 2 sodium chloride, so we'll put 2 and we'll put 2 here. So any of the alkyl halide you are using to react with sodium dry ether, just multiply, just count the number of the alkyl, all right, on the reactants. Count the number of the alkyl, multiply number of carbons, rather. Count the number of carbons in the alkyl halide, all right, and multiply by 2. You get your corresponding alkane. So one more thing again, just so it is properly clear, all right, just so it is properly clear. Now look at it. If I just tell you butyl, okay, no, let me go somewhere here. Let me see. Pentyl chloride will react with sodium in dry ether to produce which alkane? Put a question mark. Now this is pentyl chloride, pentyl, right? So pentyl is what? 5 carbon. So we are talking about an alkyl group with what? 5 carbon. So 5 times 2, 10. Therefore, the reaction of pentyl chloride with sodium in dry ether will produce what? An alkane known as what? Decane. Because decane is what? 10. And yes, 5. So 5 times 2, 10. So always just multiply by 2 That is the most easiest thing to do. So potassium chloride will react with sodium in dry ether to give you what? Decane. All right, and then you have your normal sodium chloride that will be formed. So any of the alkyl halide you are giving for Wurtz reaction, any of the alkyl halide you are giving, just multiply the number of the carbons in the alkyl halide, multiply the number of carbons with 2, and then you get your corresponding alkene. Please do it to like, subscribe, and share this video. If you still have any other questions, you can drop them in the comment section and I'll be there. Thank you very much for watching, and I'll see you in the next video.